In this video, we will learn about waves and wave motion. Now, to understand the concept of waves and wave motion, we will consider some examples. First is water ripple. So, this is what you see is water ripple. So, when we throw a small sized pebble in a pond in still water, let's say I throw a stone. So, this is how I will observe it. Okay. Now, on hitting the water surface, the pebble sinks, but the water surface get disturbed. Now the disturbance spread outwards in the form of concentric circles, just like this. So it is spreading outwards. Okay, now if a cork piece is gently put on the disturbed water surface, the cork piece simply moves up and down but does not move away from its equilibrium position. Now this shows that water mass as a whole does not flow outwards and only a moving disturbance is created which travel outward towards the edge of the pond as water ripple. You can do this in a bucket at your home as well. Now second is wave in a string. Now we take a long thin string and fix one of its end to a rigid support and we hold the other end of the string such that it is taut. Okay, this as you can see in this first figure. Now we gently give a gentle up and down jerk to the free end of the string with our hand and we observe that the whole string starts oscillating up and down as shown in this particular figure like this. Okay. Now the disturbance travels from the free to the fixed end of the string. Now from this example we can say that a wave is a disturbance that moves through a medium such that the particle of the medium set neighboring particles into motion. They in turn produce similar motion in others, although the medium particle do not move forward themselves, but the disturbance is carried forward. Now, what is the definition of a wave? So, a wave is any disturbance that propagates through a medium due to the repeated vibratory motions of the medium particle to and fro about their respective mean position. A wave transfers energy as well as momentum but does not transfer mass or matter. This is a very important line. Now the whole statement it means is suppose this is a bell and it starts vibrating. Okay, so bell is the source of a sound. Now this bell will make these medium particles vibrate one by one. Now this bell will make this first medium particle vibrate by its vibration. Now this will vibrate in its own space about its own mean position. Now the first particle will make the second particle of the medium vibrate in its own place, likewise the third and likewise the fourth and so on until it reaches our ear. Okay. Now what is wave motion? So the motion of energy disturbance through a medium in the form of wave is called wave motion. Now in a wave motion through a medium, the medium particles periodically vibrate to and fro like this about their equilibrium position. Okay, and simultaneously they transfer energy, that is disturbance, to the neighboring particle. Okay, like this first particle was giving its energy or disturbance to the second particle and not directly to our ear. Okay, in this way energy or disturbance spread throughout the medium but there is no actual transfer of mass or matter as a whole. Okay, requisites of a medium for propagation of wave through it. Now, a medium should possess the following properties for propagation of a wave. First is the medium should be elastic. What it means is that the particle after the vibration should return to their original position. Okay. Now, the medium should have inertia so that medium particles may possess mechanical energy. And without mechanical energy, the transfer cannot happen. That is why it is very important. Third is the medium should be frictionless because if there is friction between these two particles, let us suppose they're transferring energy, let us suppose they're transferring 10 joule of energy from the sound, that is vibrations from a source to our ear, then if friction is there, then the energy will get lost and which means that we will hear the sound less. Suppose it is giving 100 joule of energy, then we might only get 10 joule if there is friction. So the medium should be frictionless, as there is no energy loss when a wave is propagating through a medium. I hope this topic is clear to you. Thank you.